Okay, Chapter 9, Section 3. In this video, in the Apprentice video, we're just going to begin by comparing different methods that we've used in the past to solve systems of equations. And of course, when we're solving the same problem, even if we do it a different way, we should of course still get the same answer. So in the first equation here, or the first question I should say, it says solve by substitution and then by graphing. And then over here it says solve by elimination and then by graphing. So what I've already done is the first equation I've just checked off in blue, the second one is in red. I've actually already on the right expressed it in slope-intercept form, because when it comes to graphing it, this form is just a lot easier to work with. Okay, so all I need to do over here for each system and over here is to solve by substitution, and then below I will graph them. So feel free to pause the video so you can get this information in, but I'm going to go right into solving by substitution now. Now remember, when you're solving by substitution, the whole point is to try and identify which variable is, well, the easiest to isolate. And if you look at this system of equations here, clearly the x in equation 2 is the simplest. So to isolate it, we can do that quite easily by subtracting 4y from both sides. So I get x is equal to 12 minus 4y. Now I substitute that into equation 1 and I just replace the x. So that gives me 6, and then in brackets I'll just leave a space there because I'm going to put it in red. And this is minus 5y equals negative 15. And then in red, remember I replace this x with this x right here. So this is review. Right. Looks kind of gross, but at least we now have an equation in terms of one variable. So this is going to give us 72 minus 24y minus 5y equals negative 15. Let's combine like terms. So here I'm going to have a negative 29y, and then negative 15, I have to subtract 72 from both sides. That's going to give me negative 87. And when I divide both sides by negative 29, it looks gross, but it's actually a nice answer. You get y is equal to 3. Okay, and you can check. 3 times 29 is 87. Now we just need to solve for x. I'm running out of room here, so you can write it below on your sheet if you have a little bit more room. So I'll just put this up here. Remember, to find x, you go back and find the easiest equation to work with. Well, I'm going to work with x equals 12 minus 4y, this one right here, but I'm going to replace y with 3. There we go. So this is saying 12 minus, wait a minute, 4 times 3 is 12. So 12 minus 12, of course, is 0. Well, there we go. So the solution to the system is x equals 0 and y equals 3. All right, now to solve this system by using the elimination method, we first want to line up everything for consistency. So I'm going to get x plus 3y equals 6, and then equation 2, which I'll do in red, that one's actually fine just the way it is. Everything's already lined up the way I want, so I'll leave that. So now we have to choose which variable to eliminate. I'm going to choose y, because I can achieve that simply by multiplying this equation here, both sides, by negative 2. Okay, that gives me below negative 2x minus 6y equals negative 12. And I'm not even going to rewrite the equation in red. I'm just going to add them vertically going down. After all, they're right next to each other. So here I get 3x, because 5x take away 2x is 3x. My y's cancel, and I get negative 6 take away 12. That's just negative 18. So to solve for x, it's quite simple. I get x is equal to negative 6. Lastly, we need to solve for y. So I'm going to go back to this equation here, my original one. So this is 3y equals 6 minus x. But remember, x is already negative, so you really got to watch your signs here. So this gives me 3y equals 6 plus 6, which of course is 12. And then divide both sides by 3. And I finish off with y is equal to 4. So that's the solution to my system. x is negative 6, and y is positive 4. Now to finish off these two systems, I just want to graph what we had originally. So it was y equals 6 over 5x plus 3. So that's a y-intercept of 3. And a slope of 6 over 5, so I can go up 6 and right 5. Or I could go down 6, left 5. And I'll do that one more time because I have enough room. And it goes like that. So that gives us enough for a half decent line. And I'll just trace it right like that. That's the first line. Let's do the next one. The next line had an equation of y equals negative 1/4 x plus 3. So that actually has the same y-intercept. And my slope is negative 1 over 4. So I go down 1, right 4, down 1, right 4, or up 1, left 4. So I think that's enough to get the line in there. I think you can see where the intersection is already, because after all, that's what we're looking for. There's our line. So where's the solution to the system? It's right where they meet. Okay? And that happens to be their y-intercepts. That's just a coincidence. So the solution is at x equals 0, y equals 3. And of course, we would expect that when we solved by substitution, we got x equals 0, y equals 3. Let's do the next one. So the next one was negative 1/3 x plus 2. Y equals negative 1/3 x plus 2. So the y-intercept goes here, and using my slope of negative 1/3, my line is going to trace along these dots. Let's quickly change color, and something like that. Okay, let's do the other one. Y equals negative 5 over 6x minus 1. So there's my y-intercept. But I have to go down 5 and right 6. Okay, or I can go up 5 and left 6. Huh. I can actually see the intersection already. Let's just trace out the line right there. Okay, so the solution to the system occurs at the intersection, and that is at x equals negative 6, y equals 4, which of course is exactly what we would expect. So there we go. I'm just going to write intersection, if I leave myself enough room, which I didn't. And I'll do it over here too. And lastly, we want to explain why using substitution is not ideal for solving the following system. So notice that it doesn't actually ask us to solve this system below. We just want to explain why substitution isn't probably the way to go. Well, very simple to answer actually. If you look at either variable in either equation, all of them have coefficients in front of it. And if you were to choose any one of them and isolate it, you are going to be working with fractions. There's no way out of it. And you can do that. You will get the right answer, but it's just more work. And I would argue that elimination would be the way to go, because already I can see if I were to multiply equation 1, both sides by 3, that would cause my x terms to cancel when I add them together. So elimination would be much better. So the answer is substitution. Again, it's not bad, it's just not ideal. Substitution requires fractions. If there's a way we can avoid using them, might make things easier.